Okay, so whenever you have a fractional problem like this, where the given is a fraction, and you're trying to calculate a fraction, that is two problems, two separate problems. So the way we work it is okay, so the given is going to be 34.5 miles per second, or excuse me, per hour. Now, whenever you see the PER, think fraction. So we have okay, so that's the given. What you're trying to calculate is going to be meters per second. So when I say two separate problems, you're going to do the numerators and then the denominators. So the numerator is the top number, denominator is the bottom number. So we need to take miles to meters. And after that, we're going to take hours to seconds. And I probably need more room. Let me just do this around. Okay, so now you're going to be getting on Tuesday this sheet. Okay, it's got the metric on it, expanded metric, and it's got the boldface ones are definitions. That means they have infinite significant figures. Okay, so miles, we can convert miles to kilometers. Okay, that gives us kilometers. And then from kilometers, we can go to meters. Okay, so the meter's done now. Okay, we've got meters here, meters here. We've got hours and seconds, though. That's what we're going to deal with next. So converting hours to seconds, hours has to cancel, so it's going to be on top. Okay. So now we have seconds. So everything cancels except meters and seconds. And that's what we're trying to calculate. So whenever I check your work in lab, I use two fingers and I just go along there and make sure that everything cancels out to make sure your setup is good. And again, you should be doing the same thing. Just use your fingers, two fingers. Boom, everything's got to cancel except what you're trying to calculate. I'm sorry? I don't know. You're faster than me. Yes, that's what I got too. Okay, so all those are definitions, so they have infinite precision, meaning infinite significant figures. So the only one that matters is the 34.5, which is 3 sig figs. Hence our answer is 15.4 meters per second. Okay, so I want a key word in word problems is per, P-E-R. Automatically indicates a fraction. So sometimes you have a conversion factor built into your word problem that you don't realize you have there. So whenever you see the word per, that's what that means. Okay, are any questions about how I did this? Yeah. When you say written out, you mean like meters? Oh, that's fine. Yeah, it doesn't matter at all. Everyone hear her question? It was on units. Can you write it out like meters, M-E-T-E-R-S, or leave it as M? Either way is fine. Most of the time, you'll see in your next chem class, they're not going to use the whole word. They'll use the abbreviation, just like I use abbreviations. But you're more than welcome to write it out. If it makes more sense to you writing it out, do it. Do it. Okay. On lab 2, there's for those of you for Wednesday folks, you notice there was a number of these fractional problems. And for you Thursday folks, it's coming up. All right, so here's another problem that frequently presents challenges. Working in cubic stuff or area stuff, because the conversion factors are different. Okay, so we've got given is 1.5 cubic inches. We want to convert that to, you're right. Yeah. I saw that. Okay, we want to go kilometers, cubic kilometers to cubic inches. Okay, so we can go kilometers to meters, meters to centimeters, centimeters to inches. Each one of those needs to be a cubic conversion. And remember, whenever we have a cubic, for example, okay, in a length, one dimensional, we've got 2.54 centimeters in 1 inch. But that's not cubic. So to cube that, we're going to go so that's the cubic conversion factor. Now you can leave it as 2.54 or cube 254. It doesn't really matter. I like to leave it cubed until I actually calculate it. When I'm showing this to students, I think it's clearer. When I do it on my calculator, I don't do it that way, but up here I want to do it that way. Okay, we've got centimeters to inches. Then we need 1,000 meters to a kilometer. And these all need to be cubed because we're talking about cubic. Okay, so those are our conversion factors. Okay, so let's go from cubic. Now, why don't I cube 1.5? It's already cubed, yes. So don't cube it again. The given, if it says cubic, whatever is the given, don't do anything with it. Just leave it alone. Okay. So let's get over to cubic meters now. Okay, so that gets us to cubic meters. Now we can go to centimeters. Now we're at centimeters. Now I'm going to go to inches. Now you can leave the one by itself or leave it as one cube. Either way, yeah. Oh, I need to be in. Yeah. It should be inch, cubic inch. Oh, yeah. 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 No. There. Thank you. We have a trend going with you and me. I can't hear you. Okay. Okay. All right. Does everyone see how I got those conversion factors? They have to do with these relationships here. Okay. Now, everyone, is kilometer bigger or smaller than an inch? Much bigger, right? So our number should be big. If our number doesn't come out big, something's wrong. And this is what I want you to analyzing this. You look at it and you go, is this a reasonable answer? If it's not reasonable, then there's something wrong with your setup. Also, sometimes when you have a fraction or series of fractions, sometimes you can cancel numbers out. And if you can do that if you want, you don't have to put them all in your calculator. Make sure, though, they are equal when you cancel it out. Now, with this number, you're going to have to be cubing numbers. Depends what calculator you have. If you have a TI calculator, you're going to be using the caret, which is a little goofy looking top hat. Looks like this. Called a caret. Okay, so we get 1.5. Okay, so is my answer big? Oh yeah, it's really big. So that's consistent with what I was thinking it should be. Yeah. Oh, it is. You know, it's weird because I grew up with a slide rule. Slide rules are 3 sig figs. So usually I do everything in 3 sig figs, except today. I'm training my students well. So yes, absolutely. Have you ever seen the movie Apollo 13? Anyone in here seen that? There's a scene in there with engineers. There are probably 50 engineers. All of them had slide rules. Now, slide rules are only accurate to 3 sig figs. And guess what? It got us to the moon. So 3 sig figs isn't too bad. Okay, are any questions about this? Yeah. You mean like the, you mean out here? Yeah, that's fine. Now, some of you have metric systems built into your system because you were raised with the metric system. And you can have shortcuts. Just be careful if you're doing shortcuts with a metric system. I always like to do everything to the base unit, everything to the base unit. And it usually takes one extra step, but to me, it's real crystal clear what the conversion process is doing. If you're taking shortcuts go, and then you miss the problem, I have to go back to your setup to give you partial credit. And if I can't follow your setup, I can't give you many partial credit points. So be on the safe side, always go to the base unit. Okay, are there any questions about this conversion? I know you've asked a couple already. No, if we're working in kilometers, for example, base unit would be meters. So if you're going kilometers to centimeters, for example, go kilometers to meters, meters to centimeters. So always think of the base unit, grams, meters.
So what would be an example of that
Well, for example, in this one, going directly from a kilometer to a centimeter. No, see, it's 10 to the 5th centimeters in a kilometer. Or you go in 2 steps, there's 1,000 meters in a kilometer and 100 centimeters in a meter. So 10 to the 3rd times 10 squared is 10 to the 5th. So the shortcut would be kilometers to centimeters directly.
Oh, okay.
But if you're new to converting in metric system, that's why we say go to the base unit, because it kind of centers where everything is. Yeah. How many centimeters are in a meter? How many cents are in a dollar? 100. So there's 100 centimeters in a meter. That's where the centi comes. Century, 100 years. Is that your question?
Yeah.
Okay. The people from yesterday's lab, we're doing dry lab 2. Are there any problems you'd like me to, or any techniques that you'd like me to elaborate on that you were running into challenges on that dry lab? Yeah.
I wasn't in yesterday's lab, but I went through it at.
Uh-huh.
And
Uh-huh.
there was something I didn't quite fully follow. It was the last one.
Okay. All right, let's go over the last problem in your dry lab. Okay, if you have your lab packet out, just pull it out and go to problem 20, dry lab 2. So what was your question? How to set it up or? Okay, it says price of a ream of paper. How much is a ream? 500 is a ream. That's how paper used to be sold. Now they charge the same price and they give you 400 sheets instead of 500 sheets. And because it's approximately the same size, you don't notice the difference. But normally paper is sold in reams. Okay, price of a ream of paper is $4. A ream is defined as 500 sheets of paper. Okay, it's defined as 500 of anything. Could be 500 geese, 500 students. It's just a number, it's just a unit. So a ream is like a dozen. Okay. If a sheet of paper weighs half an ounce, what's the price per pound of paper? Okay, so is your answer a fraction? Yes. So that means your given has to be a fraction. Okay, so price per pound. So price per pound. Abbreviation for pound is LB, not P. LB. Okay, so now we need a given, a fraction. And there are 3 fractions there you could use any one of those as a given. Which one you want to use? Huh? Well, it's going to be over a ream. Okay, so we're going to. And we could have used any of those fractions in there. We could have used 500 sheets / ream. We could have used 1 paper over 0.5 ounces. Any of those work as a given, because you have to start with a fraction because we're calculating to a fraction. Okay, now the way we did the given, remember we have fractions, we have 2 problems. The first one's already done. Money's on top, money's on top. Okay, money's on top in the given, money's on top in the calculated value. So really, there's only one calculation we need to do. We need to convert a ream to pounds. Okay, so okay, that gets rid of the ream. Now we need to work on, huh? Yeah, we need to somehow get to pounds here. So one way to do it is we have ounces in a sheet, not pounds in a sheet. So if we convert now to that gives us ounces. How many ounces are in a pound? 16. Okay, so we've got sheets cancel, ounces cancel, and we're left with money per pound. Money per pound. Okay. So the way I would look at this, I would do it with my fingers. Boom, 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 boom. Does everything cancel that you want to get rid of? Or is some of that stuff still around? Now, sometimes you're given excess data. You're going to get a take-home problem that is going to be challenging for you. That's why it's a take-home problem. And you're going to get a whole sheet of data. And you have to go through the data and say, useless, good, and find out what data you need to solve your problem. Let me give you an example of a problem. When you burn jet fuel, kerosene, you produce carbon dioxide and water. Okay, when the plane flies, that water turns to ice in the air. That's why you see a contrail. It's a white trail of ice. So the problem was, you're flying out of Seattle to Los Angeles in a 737. I give you the fuel rate, how much kerosene is used, and I also give you the rate of the conversion from kerosene to ice. And it takes an hour and 30 minutes to get there. How much ice is produced? That would be an example of a take-home problem. So you have to go through all the data on the sheet and figure out what's needed and what's not needed. Because that's life, especially in our digital age. Our phones bombard you with data. And a lot of it is useless. It's not pertain to anything in your life. So you have to figure out what's useless and what's not. So that's the basis of this problem. And you're going to have days to do it. And most likely, could someone send me an email to remind me, post take-home problem, to remind me to post it tonight? It'll be under Canvas files, test related. Okay. All right. So that's the setup for this problem. Let me, oh, one other thing. Whenever you're working with money, it's always 2 decimal places. So round to 2 decimal places, regardless of the sig figs, unless the sig figs are more than that number is. For example, if your answer is $1.5, make it $1.50, $1.50. Okay, so money, 2 decimal places. Money is kind of an exception when you're doing sig figs. Okay, so let me do this real fast here. Okay, we have 4. So 26 cents a pound. Okay, does that make more sense? And that's a good example on a test question. All right. Now I'm going to end the lecture early today again, because we have our lab. You have to check in and do inventory in the drawer. Then you have dry lab number 2. So it's quite a long lab. So yeah. That's fine. Yeah. You can always do stuff in scientific notation if you want, always. But remember, the purpose of scientific notation is to make things less awkward. So if your scientific notation conversion makes it awkward, well, you're defeating the purpose of scientific notation. Okay, so let's look at a test. Now, I will be giving you this thing for your tests. So you don't have to memorize the metric system. Although many of you have used this in other countries, you've already got it memorized. And again, the bold-faced are by definition. And it's just accepted. Like an inch is equal to 2.54 centimeters. Most chem departments, if not all of them I've worked at, they claim this is a definition. If you look at it on a high precision ruler where you have inches on one side and centimeters on the other, I don't think it's exactly 50.54, but anyway, so most schools accept it as 2.54 centimeters. So that's why boldface. So treat it as such. Okay, so I'm going to be giving you this, and then this is the test up here. Now this was fall 2022. Okay, first one here now. And I'm going to have a practice test as well under Canvas files test related. You'll see a test one practice, and I'll have a key also for it. Okay, so we have, let's see. This. I should have did this before class. All right. All right, so that's 4,300,000, right? Okay, scientific notation. So again, scientific notation is number from 1 to 9.9999 times 10 to the sum exponent. So decimal points here, so we go 1, 2, 4, 5, 6. So it's okay. And I've maintained sig figs, 2 sig figs, 2 sig figs. So when we move the decimal point to the left, that's a positive direction in terms of the exponent, positive 6. When we move the decimal point to the right, it's a negative direction in terms of the exponent. So this is going to be 1, 2, 3, 4. And then this guy is going to be, who raise your hand if you think the number 40 is awkward? Gosh, no one raised their hand. What a surprise. Okay, normally I wouldn't have you convert a number like 40 to scientific notation. You can always do it if you want, but anyway. Okay, decimal points here. Boom. I notice I put 4. I didn't write 4.0. Why didn't I write 4.0? 1 sig fig, right. And you have to maintain the sig figs on both of them. Good. All right. So any questions about conversions? Okay. Dry Lab 1 did a lot of this kind of stuff. So a good way to study is for this test is to go over your dry labs. Go over your dry labs. All right. Sig figs. All right. So we've got a trailing 0. That means it's significant because there's a decimal point. Beginning zeros don't count. So you've got 4 sig figs. Zeros in the middle always count. So we've got what, 5 sig figs. Trailing zeros on the 500, there's no decimal point, so those are insignificant. So there's one sig fig. Okay. Were you copying this? Yeah, okay. All right, round to two sig figs. When you round it to two sig figs, you go to the third sig fig, and that determines the status of the second one. So 1, 2, 3. So that's the third one there. That's 5 or more. So we kick the 6 up to a 7. 57. Okay. Third sig fig. That's 0 to 4. So we just drop it. So it's 81. How many? I'm sorry. Okay. So the 0 in the middle there is significant, but it's past the second significant figure. So it doesn't matter. It doesn't matter what's past the 3. It could be all 9s. Doesn't matter. The only thing that matters is what's next after 2 sig figs. All right. And then lastly, we have 1,000,000.0. So how many, first of all, is that a question? That was 2 arms up, stretch. Okay, so to make this 2 sig figs, how are we going to do this? Yeah. Yeah, scientific notation would be the best way to do this. Then we have so when you can't figure it out, always go to scientific notation, because scientific notation is easy to put sig figs in. Okay, some calculations now. Now remember, adding and subtraction is not the same as multiplying and dividing as far as significant figures go. Adding and subtraction is just maintaining the lowest number of decimal places. Nothing to do with how many sig figs is in the whole number. Where multiplying and dividing is totally dependent on the number of sig figs in the number. So these are multiplying and dividing. So okay, is that right? What's wrong with my answer? Yeah, I did 3 sig figs, and I should be doing 5 sig figs. Yeah. So A and B, 1 sig fig, 6 sig figs. Our answer is going to have 1. That's 1.634808, blah, 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 blah. So the 6 determines the fate of the first sig fig. Remember, zeros in the beginning don't count, they're not significant. Now you may write, if you want, you may write down the whole number and then reduce it down to proper number sig figs and circle it if you want, or you can just write the number. Now, the only problem by not doing both of them, if you make an error, I can't see your real number to give you partial credit for it. That's the only bad thing about just writing down the answer after you round it. Okay. Conversions. Meters to yards. What do you think we ought to use on that? What? Meters to yards. What do you think the first conversion ought to be? Well, let's do centimeters. Then we can go centimeters to inches. Sounded like it's a general area. Okay, so we're gonna go. Okay, now we're at centimeters. What should we do next?
Inches.
Inches. 2.54 inches in a centimeter. That gets us inches. And then now we can go to yards. Well, there's 36 inches in a yard.
Yeah, obviously. It was like 50 safety.
Yeah, yeah. I mean, you can do that in as
Right.
well. That's not a problem at all. So convert. He was saying, let's convert inches to feet and then feet to yards, right?
Yeah, I thought you just said office. If we did it the way you're.
I mean, this is well established that 36.
Oh, yeah, not debate it.
Yeah, when you jumped on the metric system, that was the only one. And you can do that jump as long as you do it right. If you mess up, then it's hard to give you partial credit. Like going from kilometers to centimeters, that's 10 to the 5th centimeters in a kilometer, or 1,000 and then 100. Okay, and two sig figs. And you don't have to put two sig figs on your answer. I'm just doing it for clarity for you guys. Now, whenever we talk about years, you always have to specify, is this a leap year or not? I always talk about non-leap years. Otherwise, you got to put a quarter of an extra day in there to make up for the leap year. So we're doing non-leap years. Okay, so we're going, are any questions about this conversion? Meters to yards? I am going to run out of room here, so I'm going to. Okay, so years to seconds. What would be good to do on this? Yeah. If it's a generally accepted, like 12 months of the year, it's not on the chart, it's okay to use. I mean, if it's something really goofy that no one knows about, but you happen to know, but 12 months in a year is okay. Non-leap year. Okay, so let's go to months then. You said go to months, right? Yeah, okay. Okay, that gets us to months. Now the problem with months, 28, right. So months wouldn't be necessarily a very good way because there's too much variation. So what other things should we use? Days. Okay, days are pretty standard in a non-leap year. This is where the quarter day comes in, by the way. Okay, so now we're at days. We need to go to what's next? Let's go to hours. And then we're going to go to minutes. Now seconds. So we're looking at hours cancel, minutes cancel. We're left with seconds. That's what we want to do. And then I'll give you an answer. Three sig figs. Excuse me. Now, as you ran into months, sometimes we have problems with conversion factors, like months. Months aren't standard. They're all over the place. They're 28 days, 29 days, 30 days, 31 days. Just so you can't use a standard 12 months in a year kind of deal. But weeks works out better. Okay, and then the last problem, we're going from kilograms to milligrams. What's a good first step? Grams. Now from grams to milligrams. How many milligrams are in a gram? 1,000. So the answer is, with 4 sig figs, 10 to the 6. Okay, now that is a 45-minute test. No? No. 45-minute test, I give you an hour and 15 minutes to do it. So I think the dry lab problems are harder than this test. So doing the dry lab is practice, give you really solid practice. Okay. Okay. Oh, I guess I'm not. Sorry. Okay, so here we have a fraction problem, 65 miles an hour, meters per minute. We've already done an example of that earlier, but let's just do it again. Okay, so we have, okay, so we're going, okay, so it's a fraction problem. That means there's 2 problems here. The numerator on the top, denominator on the bottom are 2 separate problems. So we need to get minutes, excuse me, miles to meters. So what's a good way, you think? Huh? You'd rather do hours to minutes first? All right, hours to minutes first then. Okay, done. Minutes are on the bottom. What we want over here. Minutes on the bottom. Okay, all right. So let's tackle the next one now. Now we need to change miles to meters. What's a good first step? Okay, so we need to get kilometers on the top and 1 mile on the bottom. And let's go now from kilometers to meters. Okay, that's it. So two sig figs. Two sig figs. Okay, so next problem. Person's heartbeat at rest on the average of 60 per minute, per fraction, right? So we have a conversion factor there. How many times do they beat per year? So now we need beats per year. So we're going from beats per minute. We want to go beats per year. So it's a fraction problem, but the top one's already done for you, beats to beats. So we just need to do the bottom part. So we need to go minutes to a year. What's the first thing we need to do? Hours. And then hours, days. And then days to here. Okay, so we got beats per year. That's what we want to calculate, beats per year. And it's 4 sig figs. Okay, Earth has a surface area of 197 million square miles. What is it in square kilometers? Now notice this point value is 20 versus 15. That's a hint that it's going to be a little longer problem. Now we need to go to square kilometers. Okay, so what do you think a good first step would be? Miles to kilometers. This is a very straightforward problem, right? Okay, so we're going to go we're kind of done, huh? Okay, the only tricky part of this one is doing the square stuff. Okay. Wanted to make sure there wasn't a problem 9. Okay, so the tricky part on this is right here. And then your take-home problem is going to be worth 25 points. And one thing about fill-in tests, if it's blank, you're guaranteed to get 0 points. So don't leave anything blank. Where I'm going with this. Okay. All right. I wanted to do one small thing before we're done for today. And that is, if we're going to do this problem like, everyone do this problem at your desk. Okay. Everyone done? Okay. Raise your hand if you got the top number as an answer. Okay. Who got the bottom answer? Can anyone get the bottom answer? Okay. All right. The reason why I'm talking about this is if you don't put parentheses around this bottom number, you'll get that. Or if you use EE, you'll get the top number as well without doing any parentheses. So whenever you're faced with a problem where you're dividing a number in scientific notation, make sure that you isolate it as far as your calculator. Calculator is dumb. It thinks that if you go 3 times 10 caret 6 times 4 times 10 caret 7 divided by 5 times 10 caret 9, it does not know that the 10 to the 9th is in the bottom. It thinks it's in the top. That's how I got the 22. If you put parentheses on the bottom number, you can still do it that way. And the parentheses will tell your calculator that those numbers are together. And that's also what EE does in one step rather than 3. It sticks them together. So I'm highly encouraging you to use EE. Not, if you don't want to use it, that's fine. Just be careful though, And it doesn't matter if the numbers, scientific numbers are on top, it's on the bottom where it matters. Yeah. Huh? Yeah, because the calculator saw times 10 to the ninth. It didn't see 1 over 10 to the ninth, it saw times 10 to the ninth. That's why it went on top. Remember I said all the numbers on top, you multiply, all the numbers on, you hit the divide key. Well, that works fine, except for one problem. If you have a scientific notation number on the bottom, it doesn't work. You gotta put parentheses around it and it'll work. Okay, that's what I wanted to cover today. So it takes me a while to break all this stuff down. So I'll see Thursday lab folks in a few minutes. Oh, one other thing. Monday is going to be a work day, kind of a, okay, so I'm going to have you get in groups, small groups, just do some practice problems for the test. Okay, this unit 1 is really an important unit. I just want to spend as much time as possible doing it. Okay, so there's no new material on Monday.
Like, I know I put everything in correct, but your parentheses around the whole,
On the top, you don't really need parentheses,
only on the bottom.
only the bottom.
It's always better to.
But if you use E, you don't need parentheses at all. Let me shut this off so it'll blind us. You see now.
For like years, you said like when the non-leap years we use the 365.
Yeah.
Isn't there, like,
And a leap year, see what they do to get a leap year. It's 365.25 days per year.
364 is actually 365 because it tells 364 days in the year and not 8 years.
No, 365.
I must have been.
And then every 4 years, because it's 0.25, you get the extra day.
I thought
Yeah.
it was 365.
Does that make sense?
Yeah. So for like money, when you say like bring it out like you, that's.
Yeah, money's a pain.
You like big pigs and like this.
It's not things you're gonna be messed up because there's many pills. So we have 4 sick kids in there. But because it's money, you have to add, you have to keep the decimal on your money.
So you have the sick bit in the beginning or in the end, and
Well, sick kids are for the whole thing.
those things.
Depends.
Okay.
So
So this is like you're given like you have the so like your money like you have to do at the end. Would this be like instead of 2 sick days, it would be 7 sick days because it's money.
no, just do your problems with the sick things normally.
Okay.
And if your answer is money, then make sure it's 2 sick days. I mean, 2 different things.
So just do the problem normally. Don't worry about anything
Exactly.
with the normal rules, and at the end if it's money, just add the 2 decimal points.
Exactly.
Wait, do I round your whole 2 decimal points?
Depends on your answer. Sometimes you may round to that. Your answer has more digits in it.
Or you can just that's it.
Yeah.
Okay.
If it needs more than you add 0 to pick it up with 2 decimals.
Oh, okay. Thank you.
Yes, you go out here and then go to the right again. And you'll see that you do right. Yeah, find the rocks. Yes, this is kind of free lab, because these are free lab questions.
Oh, so that's the questions that we write in our notebook.
Yeah, so your free lab is gonna be. Title, purpose, no background. procedures, and you can summarize those. And then, materials.
Yeah.
And then there's no chemical. And then three life questions.
And where are the materials? Are they here?
You have to read the procedure.
Okay, so then I'll tell you.
Yeah, it's obtain an unknown block metric rule, right?
Yeah.
So that's material.
Yeah.
It's. No,
And then when we're doing like our dry lab, for example, the one we did yesterday, do you want us to do it in pen? Because you said like uploads better.
It's an older pencil, check your scan,
Okay,
make sure you can read.
okay,
It's some, I don't know what it is, it also depends on your scanner application.
okay,
And some of them allow you to change the contrast afterwards,
okay.
most don't, but some do. And then, you just look at it. The problem is, if I can't read it.
Yeah, yeah.
Yeah, that's what I told her. And I don't know why, I need to look at why it's pencil versus scanner.
Yeah. Okay, thank you. I've got the lab too. I was kind of stuck on this one. I was trying to look in my textbook to find the answer. I don't know if that's correct. It's solid.
By definition. So, let me just explain that. Sir. By definition, a cubic centimeter is defined as a milliliter. Now, some people write milliliters like this. I read it like that. Most chemists write it like this. I think, theoretical chemists write it like this. They're not very practical. However, okay, so what you're gonna do in the conversion, well, this is the conversion. One day.
Okay.
So what you're gonna do is on your, you're gonna put it, you'll dry it cylinder of water. And you drop it in the regular rock and the water's gonna go up. By a certain amount of milliliters. And then you can convert the milliliters to the centimeters, over the same.
Okay, so it's just changing basically
Yeah.
the unit. And I had a question just for in terms of order. Should I do this pre-lab before like the purpose and all of that? Just wherever?
Yeah.
Okay, that was all I had.
Most people don't put it up there. To me, it was just one.
Okay.
Yeah, let me do one thing, I want to get this conversion.